Okay, good morning, Year 8. Hope you're all doing okay, and hope you're feeling ready for another science lesson. Today's a good one. We're going to introduce you to some new kits that you always see in the movies for the crazy scientists. So today you're going to learn about that and how we actually use those crazy chemistry bits of equipment. So let's get started though. So here we are then, little starter to get you thinking. So I'd like you please to pause the video for 2 minutes or so, put a timer on for a couple of minutes and see if you can think about the answers to these questions here. So pause the video now and have a look at this. Okay then, so this is a think back then to what we were doing with evaporation last lesson on Monday. So let's go at the first one. So a liquid and solid dissolved together is called a what? So what's the name of that thing where a liquid and solid are dissolved together? What do we call that mixture? And of course, that's one of our many sol words. We've got solvent, solute, but this one is called a solution. So when we have the liquid and the solid dissolved together. And that was a little tricky last time because we were wondering when we were looking at that evaporating dish and it had the blue liquid inside it, we thought it was just a liquid. But no, it was actually a solution. There's dissolved solid inside that liquid. It's just we can't see it as humans. We can't see the tiny little bits of solid in there. But then we evaporated the liquid away and the solid bits then became visible to us. They were left behind, but we couldn't see it. It looked just like a blue liquid to start with, but really it was a blue solution. Second one then, evaporation separates what kind of solids from liquids? So some type of solid from some type of liquid. So probably got a 50-50 chance with this one. And this one, of course, is soluble solids. Okay, so if it was insoluble, that means it wouldn't dissolve like sand. And we could just use filtration to separate that from a liquid. We can use filtration to separate insoluble. But evaporation even allows us to get stuff that's already dissolved, soluble things. We can get soluble things back using evaporation. And then looking at the particles and what they're doing in evaporation for the third one, which particles are which? So we've got these blue ones, which are the ones that are leaving the top. So we can look from the picture and we see we've got liquids down here because they're close together, but they're not in any order. So we've got blue liquid leaving at the top. So that one, of course, then is going to be our water particles. That's our water evaporating off the top. And that means the one we've got left behind must be, if we talk about salt water, okay, talk about salt water. So the water is up there. The other bit we have then is the salt. So these are the salt particles that are remaining. The salt doesn't evaporate because it's still a solid. We're not heating it up enough to turn the salt into a liquid or into a gas. It stays as salt and then it crystallizes on the bottom of our dish. So quick recall then back to evaporation from last time. So I just wanted to put this slide up to make it a little bit clearer about what we've done so far. So we've been looking at these separation techniques, way of separating mixtures into their different parts, okay? And if we write them like this, we've got 3 techniques now, and the third one we're coming on to today. Filtration then separates insoluble, like sand, stuff that doesn't dissolve, solids from liquids. Evaporation separates, and we just did this, soluble solids from liquids. So you can see what we're doing is we're trying to separate more and more complicated things. To start with filtering, we had, okay, we've got some water and some sand, and I want to separate them. Well, that's okay. We just filter them. And then we went a bit harder. We said, but what if I've got some salty water? That doesn't go with filtration because the salt goes through the filter paper. So how do you separate that? And we go, well, we can do it we do it with evaporation, like we just talked about. We can have an evaporation dish, and we'll have the salt then crystallize it down here, and the water evaporating away. So we'll have got the salt back. We'll have separated the two. And now we make it even harder. So today we're going on to distillation, okay? And distillation separates, and it can be either liquids or solids. So I'll put solids or liquids. Oh, sorry, whoops. There's a space for it there. How nice. Solids or liquids from a liquid, and it keeps the liquid. So our next one was in evaporation, we do get the salt back, but we lose the water. The water evaporates away, we've lost it. The new challenge is, can we have a way of keeping the water as well? Can I somehow trap this water that evaporates and get it back? And the answer is yes, we can trap this by doing this technique called distillation. So this way we can separate either, if we've got sand and water, we can get separate the sand of the water, or if it's salt water, we can separate the salt and the water, and even different types of liquids, even though we're not going to talk about that too much today. But for example, we could have ink and water, and we can separate them using this special technique. So this is our third way of separating different types of mixtures. Okay, I just draw your attention to the OneNote for today. So as you've already seen, we've done our starter. We're now going to move on to this next task. So we're going to look at the equipment we need to do distillation. Okay, and what I've got for you over here for the OneNoters is the diagram all drawn out, and it's there ready with the arrows for you to label. If you're doing this on paper, what you can do is the PowerPoint's up here, print off, just print off this slide, okay? And that means you won't have to do all the complicated drawing. It's a little bit trickier today, so you can print this off if you want, or of course you can sketch it all if you want to do that, but that might take a little longer. Okay, but it's all there for you. So let's go and have a look at what distillation is doing. And so this is the bit I was promising you. This is the crazy scientist bit where you have Bunsen burners going over here, a round glass beaker over here, thermometers sticking out of everywhere, and you have this special tube, and this tube ends up having little pipes coming out of it for water, and then you get a little drip, drip, drip down here, so like you see in the movie. So we're going to explain what's actually going on with this crazy scientist setup. So what we're going to do, we're going to start down here, and then we're going to work our way around like this, labeling as we go. Okay, so first thing we need to label is our heat source down here, and I'm hoping all of you can remember what one this is called from last time. So have a little think and see if you can guess for yourself or remind yourself, what is this piece of equipment called? And of course, then this one is our Bunsen burner. And then we've got this stand up here, this stand, which in the diagram is tricky to draw, but we know in reality it has 3 legs. So what's the 3-legged stand called? If I try to draw it in 3D, it would look something like this. And that then is our tripod. Tri for 3, like triangle has 3 sides, pod for feet. Okay, so Bunsen burner and our tripod, and here's a new bit of equipment that you may not have seen before, but this is a round-bottomed flask. Round-bottomed flask, because it's got a round bottom. Okay. And this is what we've got our solution. So we can see our solution is in here. For this example, we might be talking about salt and water. Okay. So here's our salty water solution then in here. And then what we've got then is our flame underneath. So we know what's going to happen. This is very similar to our evaporation setup, except instead of being in a evaporation disk, It's in our round bottom flask. And so let's have a think. What's going to happen then to the solid salt and the liquid water in our mixture up here? So have a little think. What's going to happen to, first of all, the salt? What about the liquid as well? So we're not going to heat up the salt enough for the salt to melt or do anything. So we're going to have the solid salt not change, but the liquid water, that's going to start to boil and evaporate. Okay, so same deal as our evaporation, and the liquid is going to evaporate, turn into a gas, steam, and rise up here, leaving behind our salt on the bottom. So we'll end up getting some salt crystals down here. But this is where we do one better than our evaporation technique, because whereas before we'd have lost our water up here, we've now got it trapped. Okay. So we've got this bit of equipment up here, which hopefully you can remember, but that's our thermometer, just to check how hot everything is. We've got to be careful in this experiment because things get very hot and you don't know whether it's safe to touch this glass. Okay. If we've got the thermometer saying it's very hot, we know not to touch the glass yet. But once the thermometer shows us that everything's cooled down, we know it's okay, and then we can touch the glass. But what happens is we got our gas, it can't go at the top, so it then goes through this tube into this special crazy scientist piece of equipment, which is called a Liebig condenser. Okay, so Liebig after the guy who created it, and then condenser, because what we have here is we got a tube in here, and what the tube has got, it's got like a jacket around it, which is hard to draw in 2D, but this is what we've got on here. We've got a jacket around it, another glass thing, where we pump through cold water. Okay, so I'm wondering if you can have a guess then at what's going to happen to the, we've got our gas come through here, and then it's going to be very close to the cool water. So what do you think is going to happen to the temperature of our hot steam when it gets near the cool water? Yes, so the cold water is going to cool down our steam, and the clue then is in here. Our gas is going to condense. It's going to go from a gas back to a liquid because it gets cooled down in our Liebig condenser. Okay, so steam goes up here, condenses in here, and then when it turns back to water, we're going to get it dripping then down out this end into our beaker and collected. So there's our beaker. Down here. Okay. And remember, the salt isn't going to evaporate. The salt is going to stay here. So this is just going to be pure water gathering down here. We've separated and we've managed to collect the water in our beaker. We can then, once everything's cooled down, we can take our round bottom flask off here and we can scrape the salt out from here too. So we've managed to separate the salt, the water, and we've managed to keep everything. Okay, so that's one of the big advantages of distillation. We can keep everything when we do it this way, but it is a more complicated experiment to set up. So, challenge for you guys then. What we've got is the setup again, and I'd like you guys, please, to summarize what we've just been discussing with this process of distillation. I've got some keywords for you down here, but as it says in the OneNote, so we've got our OneNote task as well, I'd like you to send your summary to me in our one-to-one chats. So if I go on to our chat, so go on to chats, find Mr. Gibson in here. Obviously it can't find me because I am Mr. Gibson. And then I'd like you please to send me your summary of distillation using those keywords that we've got in here. Okay, doesn't have to be very long, just a few sentences, but I'd like everybody please to have a think about that for, you can put a timer on for 5 minutes or so, and then I'd like you to please to send me your summary. Okay, so now that you've sent me the summary, we can move on to the next step. So next step is to show you the slightly disappointing version. Okay, so Liebig condensers, these ones over here, they are very expensive. They're made of glass and they're very delicate. So normally we do not trust handing out loads of them to people because they're quite expensive. So if we were in school, this was the experiment we would do instead. We would just have a boiling tube with a little glass nose coming off like here. And this is how we would do our experiment instead. We don't have the water cooling jacket around the side to keep it cool. But normally for our experiments, it will condense just because it's away from the flame. So it'll be hot here, hot in here. But by the time it gets up into here, it will have cooled down just because it's away from the flame and the air is cooler. And we still get some condensing down here. Okay, so this is our school version of this setup. Okay, and yes, we'd have to be very careful. So if we're reading our method, we'd set up the apparatus like here. We'd have 2 clamps to keep the glass tubes in place. So we'd have a clamp for this tube and a clamp for this tube to keep them both in place. And then we'd have to be careful with the heat as well. Okay, we don't want this bubbling too much because otherwise the stand will start to shake. So normally we put the heat on so we get some condensation. But if it starts bubbling, we'll just take the Bunsen burner out the way and let it cool a bit. Then we'll put it back and then we'll take it away. And this way we'll gradually be able to distill our solution. So what I'd like you to do now to get a feel for this bit better is if you go into the OneNote, I'd like to watch this video of someone doing this experiment with water and ink. Okay, so that's two liquids. And we, like I said, we can do distillation with liquids or solids. Okay, the good bit about the liquids is ink has a higher boiling point than water. Okay, so you can imagine if I have this setup then in here, if I have my water and ink now in here instead of salt and water, and if water boils at 100 degrees and ink boils at 118 degrees, if we're careful with the heat, we can boil the water by getting up to 100, but if we keep taking the heat away, it won't get hot enough for the ink to evaporate. That means the ink will stay here as a liquid in the bottom of our flask, whereas we'll still get the evaporation of our water and we'll still be able to collect it. Okay, so we can use this trick with different liquids as well if their boiling points are different. So, link is here then for you in the OneNote. So go and click on this link then and go and watch this. Okay then, so nearly there, on to the final task. Got to do some notes just to summarize what we've been doing. So it's in blue because we know that blue means you've got to write it down. So this is blue for your notes. And if you're a OneNoter, I've got this page with the blanks ready for you to fill out on the OneNote page. But let's go and have a think about this together first of all. So have a read through this and see if you can work out what some of the blanks are. See if you can work them out for yourself first. Okay, so first bit then, to separate we can either have solid or liquid here because we know distillation works with both. It can do ink and water, or it can do salt and water, solid or liquid. But it does separate it from a liquid, and we get to keep the liquid. This is the good bit. Okay. Process is called, so yes, we do call it distillation. But if we're being very specific, this type of distillation we've just done is called simple distillation because it's not too complicated. We just have the one thing heating up and then we're just collecting one liquid at the end. Okay, so we call this simple distillation. During this process, the mixture is heated up and the liquid what? What happens to liquid when you heat it up? Yeah, so the liquid is going to evaporate. The liquid evaporates. This gas is then collected and then, so gas back into a liquid. What's that phrase? What's the term for going from gas to liquid? This is condensing then, so condenses back to liquid by cooling it. Either you can cool it just by having it in the air away from the flame, or if you're being fancy, you can get your Liebig condenser and you can have your cold water pumped in and out to keep this nice and cool as well and get even more condensation. Okay, so those are your notes then. And what I'll do then is we'll keep this for now. No, discard that. I'll just show you down here. We've got our plenary task now, which I'm going to show you in a minute. And what I'd like you to do for those is to send me your answers in the same one-to-one chat. So just as you sent me your summary, send me your answers to 2. Don't have to do all 3, but you can choose 2 of the 3 questions and you can send your answers to me. And then we've got our challenge down here if you still have some time left at the end of the lesson. How would you separate a mixture of sand and iodine? And iodine is that purple solid that sublimates. It goes straight from a solid to a gas when you heat it. And when it goes, when you cool it down, it goes straight from a gas to a solid, and that's desublimation or deposition. Okay, so that's your challenge if you get ahead. But let's have a look then at our bronze, silver, gold questions. So, bronze, what is the name of the special glass tube that allows cold water to flow around it? Silver, what is an advantage of distillation over evaporation? And the gold one, describe the changes of state that occur when distilling water from salty water. So what happens to that water between the starting process and the finished process? Okay, so you can choose 2 of those and you can send them through to me in the chat. Okay, and once you've done that, well done, you're finished for the day. Unless you want to go and have a look at this extension question. But otherwise then, I will see you guys on Friday. Okay, bye-bye.